So in this video, we are going to give you a demonstration how we can teach the digital output settings or the analog output settings of the device by using the teaching wire, which is the yellow color teaching wire of the device or pin 5 of the device. So let's see what are the options available. This video specifically, we are preparing it for the 8 meters version. So the module that I am using over here to show demonstration is UTR8M. It's a connector, M12 connector is there on the module, M12 5-pin connector. And it is UTR8M 30-8 meters is the distance, and DB, it is with the combo module. It is with combo output for analog. That means you can choose between voltage and current output. And it is IL2, that means it also supports IO-link communication. Default specification of the device, we have the measuring range from 600 to 8000 mm, that is 8 meters, 0.6 meters to 8 meters. Analog output, we have voltage and current, and digital output we have push-pull type. So this NPN or PNP type, it is selectable via wiring. So if you are going to do the wiring with respect to PNP, by default you will get it like straight output for PNP, that is normally open type. But if you change the wiring as per NPN, the structure of the output will get reverse, like normally closed type. But there is option inside the software. If you connect the device to at logic, if you connect the device to at distance, or you have UTP, you can do change the settings to NONC also. Okay, so it is also having digital outputs which are push pull type. You can do connect PNP or NPN type both. So by default, when you purchase the device comes with factory default parameters which are digital output. So by default, it comes with factory default parameters. In case of digital outputs, the parameters are the operating mode is area by default. Output is normally open type. Hysteresis is 100 mm, and setting point is 6000 mm, that is 6 meters by default. That means if you are measuring a distance below 6 meters, the output will be on for the PNP type will be on, and above 6100, that is 6 meters 100 mm above, the output will be off. So this is the hysteresis of 100 mm in between. Okay, vice versa, if we look at the analog output, the default output type is current output, and the mode is rising. Okay, so the near and far points, that means the near point is 600 mm, 0.6 meters, and far point is 8 meters. So for 6 meters, it will give you 4 milliamps, and for 8 meters, it will give you 20 milliamps. That is the rising mode. Okay, and this model is not made to measure below 600 mm range. That is foreground suppression range. Below this, you can't measure. Okay, or below 600 mm, it will give you only 4 milliamps, or vice versa. So let's look at these default settings, whether it is really present inside the device. I'll reset the device and I'll show you these are the default modes which are present inside. Okay, and then I'll show you how we can customize the teaching by using the yellow color wire. So this is the setup that we are going to use for demonstration. We can see this is our UTR device. So this is the 8 meters version device, and we will first check what are the default parameters inside the device. I'll do a complete factory reset for the device, and after the factory reset, we will check the parameters for setting the digital outputs and the parameters for setting the analog outputs as well. And then we will configure those parameters via yellow color wire. Okay, so for testing or for reading the parameters, I have used UTP here, and the mini USB cable from the UTP is coming to my PC. You can see this is the meter that is actually measuring the process value of distance, scaled in 4 to 20 milliamps. So it is giving 5.7 milliamps right now. And you can also see the digital output is right now in high position. Okay. So I'm using this bottle as an detection object for demonstration purpose. So the sound waves are fired parallel to the floor here, and they are reflecting any if any object kept in between, or if no object is there, they will be reflected from the wall. Okay. So you can see once I remove the object, the milliamps changed to 14.8 milliamps. Now let's first see what are the default parameters which are present inside the device. So I'm going to open up uh, at LiDAR. So I'm going to open up at distance and we'll verify the parameters inside. I'm adding the device UTP, connect to the UTP, and I'm having my 8 meters version device which is available. It is currently reading somewhere around 5630 mm, 5.6 meters. So the default parameters that we want to see here. Yeah. So for the outputs, the digital parameters, it by default works in area mode. Output is normally open by default. Okay. And in area mode, it basically works in with a set point of 6 meters, hysteresis of 100 mm, as we saw in the PPT. This data you will also find in uh, user manual. Same thing if we look for analog, by default, these are the factory default values. 600 is the near range and this is the far range. So you will get 4 milliamps for 600 mm and 20 milliamps for 8000. Okay, so based on that, for 5630 it is right now outputting 14.8 milliamps. Okay, let's say if you want to do reset and initialize and want to check it, okay, there is an option over here. Click this three dots, initialize the device. Okay, so after initialization, this are nothing but the same default factory default parameters that we just saw. Okay, you can also see the digital area mode is by default normally open, and the by default set point is 6 meters with 100 mm hysteresis. Okay, now what I'm going to do is I'm going to disconnect the device from the UTP, and I'm going to directly power up the UTP uh, by the wires or by an CID 5 cable, and using the yellow color wire we are going to teach the device near limit and high limit, as well as the setting point 1 for the digital output. So let's start. So I have removed the T connector of UTP and I have directly connected the CID5 cable to the ultrasonic device, ultrasonic sensor. Okay, to start the teaching process, it is important to know how we can use the yellow color wire for the teaching. So for that we can refer our user manual. So first of all, in the user manual, it is important to know for programming purpose, we need to use the input keys, which are T1 and T2. Okay. So if your device sensor does not have input keys or a display, still you can use the yellow color wire. So yellow color wire, if it is shorted to VCC, it behaves like T1 push button or the T1 input key. And if the yellow color wire is shorted to ground, then it acts like T2 key. So yellow to VCC is T1 and yellow to ground is T2. Okay. So based on this, what we will start is we will start to teach